looking at different modes, different scan types that are available in the triple. Looking at the method editor, we're typically setting up an MRM method. It's the large role of the triple in quantitation. You can see here we go through those steps as we've described. There are other scan modes, and for those modes we're going to go down to the advanced task and look at the compound information. You'll notice that there are more columns that show up here, and I'll go and show you a couple of different examples, product ion scan and neutral loss, as to how those methods could be set up. As mentioned, it's typically MRM for the triple, so this is a special case. Take a look at a method that involves a product ion scan. And again, I will go over here and use the advanced task compound setup to see all the columns involved in the compound method. There are a number of compounds here, and the transitions are existing, shown here. That one has a qualifier associated with it. I can see that in the qualifier graphic. Now, in terms of setting this method up, what I would need to do is to define first that it's a product ion scan, put in the precursor ion, put in the product ion. I would say what the range of the scan is, which would determine a display. I do not need a neutral loss fragment. I've got positive polarity, and the default over here for the criteria is greatest response, which typically works. I could pick closest retention time with qualifiers, the greatest Q value, but I'll stick with greatest response. So as you see, I can set up a product ion scan to extract the signal to do quantitation on in the method editor. Let's talk about a method editing in terms of scan modes, specifically neutral loss. Here is an example. Now, in the method editor, I need to go to the compound setup down here in the advanced tasks to see additional columns. The method editor is set up primarily to do MRM for the triple, and I need to go down to the advanced task to set up the other scan modes. So as you'll see right here, I have a neutral loss scan type assigned, which means I have a precursor ion. You can think of that as the first quad filtering, and you can always think of the product ion as what's hitting the detector. I have a scan range, which is basically what's going to be displayed when I'm looking at it. And I've also added in the neutral loss, which happens in the collision cell. Now, the best way to look at this is to check out the transition. So the transition that I'm seeing is 284 goes to 155, the loss of 129. That's the transition that will be used to extract the signal, and I can see down here that it does actually find that signal, and I can see from the spectrum the precursor ion and that loss to 155, which is the compound that I'm seeing in this particular scan. So that gives you a picture of neutral loss method setup.